Okay, good afternoon, everyone. I think most of you are here. So, can everyone hear me? Am I loud and clear?
Doctor, we can hear.
Okay, right, good. So, before we start, I think I, 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 I was checking the participants in the ITEL, right? And I think there are a few new students here. So, if you are a new student, I'm not sure which one of you is the new student, but if you are a new student, right? Every material that we have for the applied mechanics class is on the ITEL, right? So the course syllabus is there. That's where the assessment, the grading, where test one, test two will be, the assignments and so on will be on the course syllabus. All right. And I also want you to go to ITEL, and you for this course you have to pick a tutorial question to present. All right. So go to ITEL, go to the list of names for tutorial, and choose a tutorial question for you to present. All right. The rest, I think you can ask your other classmates on what to do regarding the videos and so on. I think you can just ask your classmates. All right. So try to catch up. I think we're in lecture 3, so we're not that far. So try to study up on lecture 1 and 2, and then refer the tutorial sections if you don't know how to do tutorials. And you can also approach me if you don't understand any of the tutorial questions. All right. This is for the new students. Not sure. I think because now on the database, I have around 59 students. Okay. So if anything that you want to ask, you can ask the class rep or you can straight away ask me. Okay. So now for today, we are going to learn about the resultant and resolution of forces, but this time it's in 3 dimension. All right. So previously it's 2 dimension, it's in X and Y plane only. But now it's 3 dimensions. So now we have X, Y, and Z. Okay. The difference is before this in 2 dimension, you can only go upwards, downwards, left, and right. Right. This is XY 2 dimension. But now you can go up, down, left, right, and forward and backward as well, right? So we have an additional axis, a 3 dimensional axis, all right? So for the first session, we're going to learn about the resolution of forces, the resultant of forces, and then the tutorial question. That's about it, right? It's the same thing. You already have the tools on how to solve 3 dimension, right? Because you know how to resolve the forces in 2 dimension, you know how to find the resultant force in 2 dimension, right? So the tool is the same. The way to calculate it is the same in 3 dimension as well, right? Just to recap, resolution is when you have one forces here and you break it down into 2 forces, right? One in the y-axis and y in the x-axis. This is called the resolving of forces. Okay. And for the resultant of forces is when you have 2 forces like this, right? And then you want to have one resultant forces. So you draw like a square and you find the resultant force here using Pythagoras theorem. Okay. So usually we resolve first. After we have resolved the forces, we calculate the resultant forces. It's the same as in 3 dimension as it was in 2 dimension. Okay. Now, the first session will be how to resolve in 3 dimensional space. Okay, before we start for the 3 dimensional space, right, you have to remember back the unit vectors. Okay, so if you remember it correctly, vector is something, a quantity that has magnitude and direction. All right. So vectors has magnitude and direction. Okay. So unit vector is a vector that shows you the direction of that force. Right. That's about it. If the sole function of a unit vector is just to show direction. Why? Why is this unit vector important? Because it's in 3 dimension. It's not in 2 dimension. 2 dimension is pretty easy, right? There's an y plane and x plane. But in 3D, you can get lost in space. All right. Okay. Granted, it's still easy for you, right? This is z-axis, this is x-axis, and this is y, right? If a force is somewhere here, we don't really know the direction of it, unless we attach a unit vector onto that force. If we attach that unit vector onto the force, then we will be able to gauge the direction of the forces, right? Just remember, this is just 3 dimension. For in physics or in mathematics, sometimes they have in 4 dimensions, fifth dimension, sixth dimension, and so on. So unit vector is very important as you have more and more dimension, right? Because as you have more and more dimension, you need to have a sense of direction. Okay, 2D it's easy. Sometimes you don't use the unit vector, it's also okay. 3 dimension, still you still be able to see it, right? Because sometimes we do the 3 dimension x something like this, so we can try to gauge the direction of the force if we want to. It's a bit difficult, but we can still try to find the direction by doing dotted lines like this. We know that it's an xy plane, this one is in z plane, we can still know, right? But what if it's in 4 dimension, 5 dimension, 6 dimension, where they have a lot of axes? Then we start to get confused. So, in order to not get confused, we use this unit vector, right? Unit vector, the sole function of that unit vector is just to show direction. And because it is to show direction, that vector for this unit vector has a magnitude of 1, right? It has to be a magnitude of 1. If it's more than 1, then it's going to change the magnitude of the vector. For example, here, right, you have a force here that has a magnitude or a length of 5. So its unit vector is 1, but it has in a quantity of 5. So 1 here, 2, 3, 4, 5, all in a magnitude of 1, right? It's just showing the direction, right? So if you want to construct this unit vector, you can look at here. So for example, we have a vector A, which is 3, 4. So 3 in the x-axis and 4 in the y-axis, right? If we calculated the magnitude here, the Pythagoras theorem, just use Pythagoras theorem to calculate the magnitude, you will get 5, right? But 5 is not 1. 5 is the magnitude, the length of this vector A here. So to calculate the unit vector, we have to change it into a magnitude of 1. So what do? We take the magnitude here and divide it by 5. Once we divide this one by 5, it becomes 1. All right? And once we divide this one, the magnitude, by 5, we have to divide this one by 5 as well. We have to divide this one as 5 as well, right? Once we divide everything by 5, we will get the unit vector here, which is 1, right? But it exists in quantity of 5. Okay? So if you calculate the unit vector, and finally, the magnitude of the unit vector will eventually be 1. All right? The thing here that you need to understand is just unit vector is just there to show direction, the direction of that force. Okay, so if you look here, a vector, this is a vector, right, has magnitude. This one is magnitude, and this one is the unit vector, which is the direction, right? So vector has magnitude and direction, the unit vector, right? That's why the unit vector here must always be 1, right? It has to be 1. So if it's more than 1, then it's going to change the magnitude of the vector. For example, the vector here, right? Say it has a magnitude of 2. Okay, because the unit vector is 1, say 1 here, it does not change the value of the magnitude of the vector. The magnitude is still 2, right? If the magnitude is 3, the unit vector is 1, the magnitude of the vector is still 3, right? That's why it has to be 1. If it's more than 1, for example, if the magnitude of the vector of A is 3, and then unit vector, say, for example, is 2, right? Then it will become 6. So it changes the magnitude of the vector. It no longer represents the vector of A. Okay, so that's why the unit vector has to be 1, so that it can accurately show the direction of the vector without changing the magnitude. Okay, so it must be 1. It can be -1 or +1. Negative or positive, it's just showing you the direction of the forces, right? For example, if the magnitude is 3, the unit vector is -1, so it's going to be -3, which is going to the left in the x-axis or going down in the y-axis. Okay? Remember, positive and negative sign is just to show you the direction. Either it's going to the left, the negative side of the x-axis, or to the bottom, which is the negative side of the y-axis. All right? So that's unit vector. Unit vector is just to show direction, and it doesn't, it's 1 because it cannot change the magnitude. If it changes the magnitude, if it's more than 1, then it does not accurately represent the vector already, right? So now how do we resolve forces in three-dimension space using unit vectors, right? So the figure shows a three-dimensional space with x, y, and z axis, right? So the unit vector in this direction, so in three-dimensional, we use the unit vectors I, j, and k to show the direction, right? So I, if you're using the alphabet I, it means that it is on the x plane, right? If you're using unit vector j, means that that vector, that force is on the y plane, and if it's k, it's on the z plane. So whenever a question asks you to represent the vector in Cartesian vector or in unit vector, it means that you have to attach this three alphabet to your vector, right? Because once you attach this alphabet to your vector, then we know the direction, right? Whatever vector that you attach it with I, we know that it is in on the x plane, j on the y plane, and k on the z plane, right? It doesn't matter. We are using alphabet because each of this unit vector has a value of 1. So I is 1, k is 1, j is 1. Doesn't matter, right? So if your vector is 5i, 3j, and 2k, the unit vector is 1. It doesn't change the magnitude. So that's why we leave it as it is. 5i means we know that, oh, this vector is on the x plane with 5 units, right? 3 units in the y plane and 2 units in the z plane, right? But now we know the direction because you have attached the unit vectors onto it, right? So these are called unit vectors or Cartesian vectors, okay? And it's very important when solving problems in three-dimensional space, right? So now, we can also use the unit vectors in two-dimensional space. Before this, in the last lecture, we did not because it's not really that necessary. But in order to simplify the use of unit vectors, we can start with the two-dimensional space, right? So resolution of forces is we are dividing the forces into multiple forces. So we have one main force here. We want to resolve it into two force because it's this one is just an example of two dimension. So you have one force, we resolve it into y and x. Force 1 and force 2. Resolving, right? Breaking it down to multiple forces. Okay? So now, because this is on the x plane, so we attach the unit vector I for this force here. So we know that it is on the x plane. And this one is on the y plane. we attach, okay, this is wrong, we attach the J unit vector here, right? To show you that is on that it is on the y plane, right? Once you have attached unit vectors, I think this is pretty straightforward. You can straight away calculate fx and fy, right? So this is how you calculate using cos and tan. So to calculate this one, so cos is adjacent over hypotenuse. So that's why you use cos. To calculate fy here, it's opposite over hypotenuse. That's why we use sine. Okay. Calculate the magnitude, it's just using Pythagoras theorem. So fx squared plus y squared, and then you square it at the magnitude. Okay, and then the angle is just using tan fy over fx, right? So opposite over adjacent. That's why we are using tan, right? So it's very straightforward to resolve it in two-dimension space. If you want to use unit vectors, if the question asks you to present the vector in Cartesian vectors, you have to use the I and J here, right? Just attach it to the magnitude. So we know the direction where it is. It's in on the X plane or on the Y plane. Okay. So now we go to the three-dimension space. It's the same thing, but now we have an extra plane, all right? The Z plane. But how you solve it is actually the same thing, right? So you have one force here. So after you have one force, resolving it, you need to resolve it into the X direction, resolve it into the Y direction, and you need to resolve it into the Z direction, right? So previously, you only resolve it into two forces, in the X and Y plane. But in three dimension, when you are resolving a force, we have to resolve it into three forces. Three forces in the I, in the J, and in the K. Okay? X, Y, and Z plane. So just draw it, the fx here, fy here, and fz here. And once you have drawn it, you can straight away calculate it, right? See here, so you can use cos adjacent over hypotenuse to calculate fx, like this one here, right? For fy, it's the same thing. You're using cos because it's adjacent over hypotenuse, all right? Adjacent here over hypotenuse. It's in here. And FZ is the same thing. If you make it into a triangle here, right? So it's adjacent over hypotenuse. Adjacent over hypotenuse. That's why we are using cos. Okay? So therefore, you will have something like this. Your magnitude cos theta x, I, then the calculation, and then this one is J, and then this one is K, right? This is how you solve it in three dimension. You must always have this I, J, K at the end of your calculation. So we know that this part here is on the X plane, this part here is on the Y plane, and this part here is on the Z plane. Okay, so it's just the same thing. You're basically resolving these forces here, but this time you are dividing it into three forces, right? In the X, Y, and Z, as opposed to only two forces in two directions that we have learned last week. Okay, so these are the formulas that we will be using. So you have to remember this one. There's only three formulas for this chapter that we will be using. It's from Pythagoras theorem. So f is equals to fx squared plus fy squared plus fz squared, right? This is just the alphabet f. But basically the f, the meaning of that is the resultant force. So resultant force is equals to force 1 in the x direction, force 2 in the y direction, force 3 in the z direction, right? Understand the theory, don't just remember it blindly, all right? This is just the alphabet. Sometimes in the question, I change the question to have the value R or F1 or Z or whatever, and then the student gets confused because in the formula it's just F, 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 and there's no F in question, right? No, you have to understand the theory, right? The theory is just whatever resultant force is equals to the individual force in the X direction plus that individual force in the Y plus that individual force in the Z direction. Okay, so this is your resultant force. This is what you have resolved into the X, Y, and Z direction. So this one has to be equal to this one because it's just resolving the same forces but into X, Y, and Z. All right. And to calculate the magnitude, it's pretty straightforward. It's using Pythagoras theorem, square, and then you square root it. And then if you substitute this fx, fy, and fz with the magnitude f and theta, right? Substitute this one and this one into here for each and every one of this one, you will have another equation, which is this one here. Cos square theta x plus cos square theta y plus cos square theta z is equals to 1, right? So 1, 2, 3 equation that you need to understand, right? So sometimes when you're stuck when doing a question in the tutorials or in the exam, just remember this 3 formula here, right? Usually when you have more than one unknowns, 2 unknowns, then you have to use either one of this formula to cancel one unknown, right? For example, if you have theta x and theta y, but you don't have theta z, then you can use this equation to find theta z. Okay? You use the formula when it is necessary. For example, if you have x fx, you have fz, but you don't have fy, then you can check this equation and use it to find fy. All right. Usually, when you cannot solve a question because there's more than one unknowns, most of the time it's because you need to use one of this equation here. Right. Try to understand it. Try to memorize. Not memorize it because I'm going to attach this one uh, on the formula sheet for your test and your final exam, but at least try to understand the reasoning behind it so that when I change the alphabet or maybe change the question a little bit, you still have the tools, you still know which equation to use, right? There's just 3 equations for this chapter. So don't worry, try to understand it the best that you can, right? And the best way to understand the use of this equation is by doing a lot of exercise, right? So applied mechanics is an exercise-based course, right? You have to do a lot of exercise for you to finally be able for you to finally be able to comprehend how to solve a particular problem, right? That's why what I keep telling you guys when doing the tutorials, right? I want you guys to do the tutorials first, right? Even if you don't know how to do it, just do as best as you can. And when you are stuck, it's because that you are stuck that's when you are using your brain and try to solve it, right? If you cannot even solve it, at least when you look at the tutorial videos that your classmates have posted, you understand it. I see, that's why she did like that and so on, right? But if you do your tutorials straight on, you don't even study the tutorials, you straight away look at the videos and you look at how your classmates solve it, trust me, you're going to have a problem in your test or your final exam because you do not have that analytical thinking yet. You have to do a lot of exercise for you to be able to know, okay, first I need to solve this part first and then solve this part, and only can I solve the whole picture. All right. You have to have an analytical mind to do that. If you straight away look at the tutorials, you straight away you kind of have like a shortcut where your classmate is telling the okay, you have to solve this one and this one and this one, so it's kind of like linear. But actually when you're assessing the system and solving the problem, it's not linear, right? Sometimes you have to solve certain parts and analyze certain parts in order for you to solve the whole picture, right? So all in all, you have to do a lot of exercises for this course. Okay. Okay, now, okay, this is pretty straightforward. Resolution of forces. This is the formula, right? 1, 2, 3, and then once you do that, you can find the magnitude of the force here. It's just using Pythagoras theorem, right? So fx square, fy square plus fz square, and then square root it, you will have your magnitude of force. All right. And then unit vector is just from this equation here. This equation is just telling you that vector F has magnitude and has direction. Right. The magnitude is the one that you have just calculated here. Okay. And then the unit vector is the one that you will calculate over here. Right. So it's the same thing as resolving of forces as per last week, but this time we do it into resolve it into three forces. Okay, so now we go to the examples, right, to show you how to do this thing in the calculation part. So a force F 300 Newton in three-dimensional space makes an angle of 70 degree and 45 degree with the x and y axis respectively. So determine the force component in the x, y, and z axis, then state force F in the vector form. All right. So whenever you see vector form, or sometimes they call it the Cartesian vector form, then you know you have to use the I, J, and K, right? You need to attach this one to your vector whenever you see it says that you need to state the force in the vector form. Okay. So as with everything else, the first thing that you need to do is you need to draw the free body diagram. So this is a free body diagram. Once you've drawn the free body diagram, it gets easy, right? So because this is in three dimensions, so you have your x, y, and z. And then you have your force F here, which is 300 Newton, right? So the blue ones are given in the question. The red ones are what you need to find, right? So it's straightforward. You have one force here, you need to resolve it. You need to break it apart into three forces. So first force into the x component, second force into the y component, third force into the z component. All right, just draw it fx, fy, and z. Right? For three dimension, you always have to draw it in more or less the same way. You have force here, whichever force that it is going, you have to do an arrow in the x direction, in the y direction, and in the z direction. We are resolving it onto its corresponding axis. Okay, so once you have resolved it, it's pretty straightforward, right? You can straight away calculate it. So how to find fx here, right? Just make it into a triangle here, and then you can use 300 cos 70 degree. Cos, why? Because adjacent over hypotenuse, right? Adjacent over hypotenuse. So that's why we use cos. So 300 cos 70 degree, we will have our fx, which is 102.61 Newton, right? Next, we go to the second vector, second force, which is Fy, right? If we make it into like a triangle here, something like this, right? If we make it into a triangle there, we can calculate Fy using cos as well, because adjacent over hypotenuse, all right? And the angle is already given, 45 degree, so we can solve this one as well, right? Just imagine that you're drawing a triangle, something like this, right? So you have kind of a triangle, something like this. Okay, but this one is the hypotenuse. So that's why we are using cos. Okay, so force 2 is done in the y direction. But in the z direction, we are not able to solve it, right? This z direction, we can't solve it because there's basically two unknowns here that we do not know. We do not know f and we do not know theta z. Okay, So what we need to do if we encounter two unknowns, we refer back to the formula, right? So from Pythagorean theorem, theta z can be determined using this equation here, the third equation, right? Cos theta x plus cos theta y plus cos theta z equals to 1. We use this formula because we know what is theta x, which is given 45 degree. Okay, we know what is theta x is given, which is 70 degree here. Theta y is also given 45 degree here. The only thing that we do not know is theta z, right? So you can use this formula to calculate theta z, right? So you rearrange it, and finally, because this is plus minus, you will have two answers. All right. So now once you have reached this part here where you have two answers, right? Because this is plus minus, right? Once it's plus minus, so you have two values. It can be either 51.8 degree or 1 to 8.24 degree. Okay. So how do you choose which one is the correct value for your theta z? Right? You choose it based on the graph, your logical thinking on the graph. So basically 90 degrees is this one, right? So in 90 degree is this one. So for this angle here, is it less than 90 degree or more than 90 degree? For this angle here, is it less than 90 degree or more than 90 degree from your point of view? Anyone?
No.
Less, right? It's less than 90 degree. So that's why we choose this one as the answer for theta z and not this one. Because it does not make sense for this angle to be 1 to 8.24 degree. This is more than 90 degree, right? And it does not make sense if it's 1 to 8.24 degree for this angle here. Therefore, we choose 51.8 degree. Okay, so now once we have 51.8 degree, take this one and put it back into this equation here, and then finally we can solve it and we can find Fz, right, which is 185.53 Newton. Okay, so anyone has any questions for this question here? Everyone okay? Everyone okay? Okay, good. Okay, good. So it's a very straightforward exercise. Okay. Okay. I forgot about the last one because the question wants you. Oh, can everyone hear me?
Can, Doctor.
Can? Okay, right. I thought I was muted there. Okay. Okay, now we go to exercise 2. All right. So a force P has component Px 20 kilonewton, Py negative 30 kilonewton, and an angle between force P and Z axis is 120 degree. Determine force P, theta x, and theta y. Okay. So the first thing that you need to do is to draw the free body diagram. Draw it in the X, Y, and Z plane. Okay. So the blue thing, the blue color here is already given, and the red color one is what you need to find. Okay. So a force P is given. and you need to resolve it. So draw one force in the x direction, second force in the y direction, and the third force in the z direction. Okay, once you draw that, you need to find all the unknowns, which is the red color here. All right, so px is already given, it's 20 kilonewton, but we don't know what theta x is. Py is also given, it's the magnitude is minus 30 kilonewton, but we don't know theta y. Pz here, it's p cos theta z is equals to pz. It's not given, it's an unknown. All right, so looking at this one here, it's a bit hard to solve because there's two unknowns, right? We have p here that we do not know, and then we have theta x, y, z that we don't know. So we have, as I've told you before, if we have more than one unknown, we look back at the formula and pick the best formula that we can calculate to eliminate one of the unknowns, right? So for this question, we can use this formula here, the Pythagoras theorem. The p square is equals to p in the x, in the y, and the z direction squared, right? So just incorporate everything into here. So px, we know it's 20 kilonewton, right? Py, we know it's minus 30 kilonewton, right? Pz is equals to p cos theta z, right? And theta z here is given, which is 120 degree. All right, so finally your P is 41.6 kilonewton. All right, so once you have the 41.6 kilonewton here, you can straight away put it into the unknowns here. Okay, if you put it into the unknown here, you can straight away calculate it, right? So Px is equals to P cos theta x, P cos theta y. Okay, P, we know the value of P already, so we just rearrange it and calculate theta x, which is 61.26 degree, and theta y, which is 136.15 degree. Okay, so that's about it for this exercise. So anyone has any question for this exercise? Very straightforward. It's just resolving the forces in three axes, and then using the formula, whichever formula that is suitable, to eliminate one or two of the unknowns. Okay, just showing you the different formulas that we are using. Previously, we were using the cos square x plus cos square theta y and so on equals to 1. This is just showing you that we are using this formula to eliminate the unknowns, get p, and then put it back into this equation here. Right? So everyone okay with this exercise? Anyone wants to ask question? If you are confused about anything for this question? No question? Everyone okay? Okay, good, good. So I think we are done for the resolving of forces. Okay, it's very straightforward. Resolving of forces in 3D is you have one force here, then you resolve it into the x plane, the y plane, and then the z plane. Okay, that's the resolving of forces. Once you have resolved the forces, then now you need to find the resultant of the forces. Finding the resultant of the forces is a bit easier, much more easier than resolving of the forces. All right. So this is an example of forces that you have resolved. All right. So you have one forces, and now you have resolved it into F1, F2, and F3 in 3 dimension, right? So previously you have one force, now you have already resolved it into three forces. So now we want to find the resultant force for F1, F2, and F3. Okay, so how do we find the resultant force? We just add them all up for that particular axis, right? So resultant force in the x direction, you add every forces that is on the x plane, right? So every force on the x plane, you just add them all up, right? Same thing for resultant force in the y direction. You add every forces in the y direction. Okay. Same thing for the resultant force in the z direction. You add everything in the sorry, for the y direction, it's this one. So you add everything in the y direction, and then on the z direction, you add every forces in the z direction here. All right. The only thing that is changing is the unit, the sign. Sorry, the sign. All right. If it's negative, it means that it is going in the negative direction. If it's positive like this one, it means that it is going in the positive direction. So typically, x for the x-axis to the right is positive, to the left is negative. Sorry, to the right is positive, to the left is negative. Right? That's for the x direction. For the y direction, typically going down is negative, going up is positive. Right? For the z direction, usually going forward is positive, going backward is negative. Right? So that's all that is changing is the sign, right? Negative, positive, and so on, right? For example, in the resultant force in the x direction, right? So you straight away cancel this and cancel this. You only look at forces that is in the x direction. So plus F1x minus F3x, right? This one. Okay. For the y direction, you close this one, and only look at the force in the y direction. So positive F2y minus F1y, and then positive F2y. Okay, that's how I put it. But here I think I've made this part here as the positive section, and then this part here as the negative section. All right. But actually, the signage, it's up to you, but you have to be very consistent when you're using it, right? But let's just confirm it now that here we use it as a negative and here it's positive, right? So the signage here should change. Okay, same thing as Z here. So this one is going up, so positive F1Z. This one is going down, so it's minus F3Z. So this one is going up, so this is actually positive. So I got this one wrong. So this is actually positive F2Z, right? Very easy. It's just looking at the direction of that force, right? If it's going negative direction, means going to the left or right of that particular axis, then it should be negative. If it's going to the positive direction, it should be positive. Okay, so that's about it. You add everything in the x direction, everything in the y direction, and everything on the z direction. After you have done that, you can now calculate the resultant, right? Once you have calculated the sum of forces in the Rx, sum of the forces in the Ry, and sum of the forces in the Rz, you can calculate the resultant force, but you can draw it first. For example, you have 50 Rx here, 60 Ry, and 70 Rz. So you can straight away draw the forces, right? Forces that have been resolved, right? And then you can calculate the resultant force using Pythagoras theorem. Basically, Rx square plus Ry square plus Rz square, and then you square root this 3. Okay, so after that, it's pretty straightforward. Once you have your resultant force here, you can straight away calculate the angle using cos theta x, Rx, or Ry. Right? So if your Rx here, your angle will be from that resultant force to Rx. Okay? So if it's Ry here, your theta y will be from the resultant force, this one, to the force on the y-axis. And if it's z-plane here, your theta will be from the resultant force to the z-plane, right? And also you need to draw your resultant force, right? Once you have your sum of Rx, sum of Ry, sum of Rz, you need to draw your resultant force first to know the angles, right? How you draw it is just you have to draw it into 3D, something like this, and then this one will be from the origin to the edge section of that cube, right? Something like yeah, something like this, right? So you have to draw your resultant force. You get your Rx, you get your Ry, you calculate your Rz. So then you need to make kind of like a cube in 3 dimension, and then your resultant force will be from the intersection point of Rx, Ry, and Rz. It goes all the way to the end section of that 3 dimensional cuboid, right? And then once you draw the resultant force, your theta x will be from what you have drawn, the resultant force that you have drawn to the x-axis, and y is the angle of y is from the resultant force to the y-axis, and theta z is from the resultant force that you have drawn to the z-axis, right? So you have to draw the cuboid. If it's 2 dimension, it's easy to draw the resultant force, right? You have y, x, and then you make a square, and then just this is your resultant force. But in 3D, you have to draw the cube in 3 dimension as well. Draw it in 3 dimension, and it's from the origin all the way to the edge section of that 3 dimension cube. Once you have drawn the resultant force, then only can you know where to assign the angle, right? So angle X is from the resultant to here. Angle Y, here. Angle Z is here. It has to start from the resultant force, and then it ends on that corresponding axis. If it's theta X, so it should end on theta X axis. If it's Y, it should end on Y axis. And if it's Z, it should end on the Z axis. Okay? So yeah, so that's it. So that's why you calculate, that's how you calculate the angle of Rx over the magnitude of R, right? Straightforward, it's the same thing as the calculation of magnitude and direction in 2D space. Okay, so now this is an exercise so that you can get kind of like a visualization on how to solve problems in 3 dimension. Okay, so a concrete slab is suspended by 4 cables AB, AC, AD, and AE, is shown in figure. Calculate the resultant force, which is R, and its direction against X, Y, and Z. So you need to calculate theta X, theta Y, and theta Z. If the force in each cable is 30 kilonewton, 20 kilonewton, 40, and 25 kilonewton, right? So draw the free body diagram. Once you draw the free body diagram, you have something like this, right? Okay, once you have something like this, it depends on your analytical skills, right? You have to do a lot of exercise to know how to solve problems like this, right? So if you look at the free body diagram here, there's not a lot of information here. The only thing that is given is the length, which is the magnitude, which is 2, 4, and 3, right? So what can you deduce from the magnitude that is given here, right? So because there's no angle given, there's only the only thing that is given is the magnitude, which is the length of each of these force or cables, right? We can calculate the magnitude for each and every one of these forces first, right? Because that's the only data that we have, the magnitude, the length. So we can straight away calculate the magnitude for each and every one of this cable, right? So for F2, is it hard to calculate? No, because we already know F1 here, which is 2, and then we know BC here, which is 3. So 3 square plus 2 square, and then square root it. Using Pythagoras theorem, we will have a C, right? So now we have the magnitude of F2 already. For F1, we don't need to calculate anything because it's already given. The magnitude is actually 2, and it exists on the z plane only. It's not slanting. It's directly on the z plane without any slant, right? So f1, the magnitude is definitely 2, right? And now we go to f3. Can we solve f3 with the given data? Yes, we can. If we make it into a triangle here, right, we can solve it if we know this line here, right? This one is already 2. So how to find this line here? By solving the triangle, this one first, right? So for example, this one is given, it's 3. This one is also given, which is 4. So the hypotenuse here is 3 square plus 4 square, and then square root this one. You will have the magnitude of this one. Okay. Once you have the magnitude of this one plus this one, 2 square, using Pythagoras theorem, we will get our f3 here. Okay. So the same thing for f4 to calculate it. This is a triangle, right? It's very straightforward. This one is given is 4. This one is 2. So calculating using the Pythagoras theorem, so 2 square plus 4 square square root, we will have AF or F4. All right. So you calculate the data that you have first, right? So length is given, which is the magnitude. So you try to calculate the length of the magnitude for each and every force here, which is this one, right? So I've calculated for F1, which is 2 meter. F1 is this one, which is 2 meter, and then calculated F2, which is using Pythagoras theorem, F3 also using Pythagoras theorem, and finally F4 also using Pythagoras theorem, right? So now we have the magnitude of all the forces, F2, F1, F3, and F4. Okay. Once we have the magnitude, we need to tabulate it into a table, right? Into the X, Y, and Z, right? So now it's easy. You're just putting in all the values inside of the table here. You just need to be careful about the signage, right? So the signage depends on if it's going to the negative axis or the positive axis, okay? So just put everything here in the table here and then finally calculate the resultant force. Add all this up to calculate the resultant force in the x direction. Add this one up to get resultant force in y direction. Add this one up to get the resultant force in the z direction. All right. So I want all of you to use the same way. All right. Once you solve this problem in 3 dimension, I want everyone to make it into a table. It will be easier for you, and it will also be easier for me to mark your solution, right? Because I'm not sure. I've been teaching several students, right, to do it like this, but in the end, during the final exam, they did not make the table, right? They do something like f1 equals to f2 x plus f2 the x plus something x. They do it in that form, right? Can be a bit confusing for you. If you do it wrongly, you will have your marks deducted, and then it's also hard for me to mark that kind of solution, right? It's easier for me if you make it into a table here and just show me for the force one here 0x, 0y, and z direction, and so on, right? So you tabulate this and calculate your sum of Rx, Ry, and Rz, right? Once you get this one here, you can now draw your resultant force, right? You have your Rx now, you have your Ry, and then you have your Rz, right? Now you can draw your resultant force. Okay, this is just the calculation. Yeah. Okay. So it's okay if you want to do it in the form something like this, but in the end you have to make it into tabulated form, something like this as well, because it's easier for me to mark you guys when you do it into tabulated form like this. Once you've done into tabulated form like this, you can calculate it like this to show me how you get the answers and so on. And it's also for your reference when doing your calculations, right? But I appreciate it if you include this table here so that I know which one is in the X, Y, Z directions and so on, right? So this is just the calculation of resultant force in the X direction. This is in the Y direction, and this is in the Z direction. Okay. Once you've add everything up, you just use Pythagoras theorem. So this is the sum of R in the X direction, in the Y direction, and the Z direction. You square everything up, and then you square root it, and finally you have your resultant force, which is 93.4 kilonewton. Okay. Then you can draw it, right? So this one, you've calculated it. Your sum of Rx is negative 52.1 kilonewton. So from origin, it goes to the left, right? Negative 52.1. And then your Ry is also negative 38.9. So from origin, it goes up. I'm not sure why it's negative. It should be going down. But I guess for this question, I made this as the negative part of the coordinate, and I made going down the positive part. All right, so that's why it is negative here, right? And then going up here, it's 67.1 kilonewton, right? And then you make a cuboid, right? And then from the point of intersection, it goes to the edge section here. So this is your resultant force, 93.4 kilonewton, right? Once you have drawn from this part to this part is theta x. This part, the resultant force to the y plane is theta y. And this part here to the z plane is theta z, right? And then you can straight away calculate. It's very straightforward because you already have the resultant force in the x direction. We also have the resultant force magnitude, right? So calculate theta x, calculate theta y, and calculate theta z, 44.1 degree, right? Okay, I think for this one, this is the point of origin. So x here is positive, going here is negative, all right? So for this question, I made going down is positive, going this one is negative, right? But this one is positive, this one is negative, all right? So this one is not actually, it's not rigid, right? It's actually flexible. It actually depends on you when you are solving it, right? You can actually make this one as the negative section of the x-axis, and then this one is the positive one, and then you can make this one positive as well, and then negative. It's all up to you, but you have to be consistent regarding it, right? If you're consistent, eventually it will cancel out each other. We will get the same answers, all right? But from now on, we use the standard one, right? Which is this one is positive, going here is negative, and then y, this one is negative, this one is positive, and then for z-axis, this is positive, and then this one is negative. All right, that's the standard one that I'm using. But I think for this question, I made it the other way around, so that's why this one is negative 38.9 kilonewton, right? But for other questions after this, you use the standard signage for the axis. Okay. All right. So, any questions for this one? Everyone okay? I think it's very straightforward. It's the same thing as previously as last week. We just divide it into x, y, z, calculate the resultant, draw it, and find your angle of theta x and theta y and theta z. Okay. So I think everyone is okay. So now we go to the last question, which is this one. So a pulley was pulled by using wire with forces as shown in the figure. Determine the resultant force acting on nail given line AB are in plane X, Y. Right? So AB here is on the XY plane, but these two forces is not on the XY plane, right? So what we need to do, we need to resolve F1 and F2 first. We need to resolve F1 and F2 to get this one here. And after we get the force here, we can resolve it further so that it is on the XY plane, right? Because right now you have something like this, right? You have something like this, and then it is vertical, right? So we need to find the bottom part of that triangle. And once we have this bottom part of the triangle here, for example, the pen here, we can remove this one, and then we can resolve it, this force here, into the X and Y plane. Because right now it's something like this, right? So we need to find this one here so that we can find it on the XY plane after that, right? So find this one first, and then you can resolve it on the XY plane later, right? So this one is actually this one, right? 200 Newton, 45 degree, right? So 200 Newton, 45 degree. So we resolve it into FA and F1Z, right? So resolving it is pretty straightforward. This one is actually two dimension. So 200 cos 45 degree cos because adjacent over hypotenuse, right? Get 141.4 Newton. Okay. For F1Z here, we're using sine because opposite over hypotenuse. So 200 sine 45 degree, get the same thing, 141.4 Newton. All right. Once you have FA here, now we can revert it into the X and Y direction, right? So that this one is what we have calculated just now, right? So previously, the triangle is something like this, right? This is the triangle. It's not on the XY plane. What the question one is on the XY plane here, right? So that's why for the triangle here, we try to get the force for this one, right? Once we got the force for this one here, we resolve the force again so that it lies on the Y and X axis, right? So now we resolve it straightforwardly. 141.4 cos 30 degree, we'll have F1x 1 to 2.5 Newton and F1y negative 70.7 Newton. All right. So that's that. We've solved it. All right. Now we know the forces that is on the X and Y plane. Okay, it's done. So now we go to the second force, which is this one here. It's the same thing. This force does not lie on the XY plane. It lies on the YZ plane. Right? So we need to resolve it first. Resolve it into F2Z and FB. Right? So 150 sine 50 degree, you will have FB here as 115 Newton, right? And then F2Z here, 150 cos 50 degree, we have 96.4 Newton, right? Because cos adjacent over hypotenuse, and then this one sine because opposite over hypotenuse, right? Once we do that, once we calculate this one, 115 Newton that we have just calculated here, which is your FB, right? It's 115 Newton. We can now resolve it into the X and Y plane, right? Because previously, this one here is actually here. It's actually here, right? Okay, I'm not doing it. It's actually like this, right? So it's not on the, okay, I'll make it into triangle so it's easier for you to see. So previously, the triangle is something like this here. It does not lie on the XY plane, right? So you resolve it, and then you try to find this force here, right? Once you find the force here, you can throw this one away. Okay, you have this force here, which is 115 Newton. So you resolve this force here. And once you resolve this force here, you know that the resolving forces will be on the X and Y plane, right? So once you resolve it, pretty straightforward. F2x is 115 sine 20 degree, 39.3 Newton. And F2y is FB cos 20 degree, which is 108.1 Newton, right? So now you put it into the table here and differentiate it into the X, Y, and Z. Just put everything here. Make sure you get the right signage. And then you calculate the resultant force, 290 Newton. Okay. Once you calculate the resultant force, you have to draw it so that you can know where the angle is. Or it ends there. Oh, okay. The question doesn't want the angle. It only wants the resultant force. All right. So that's where you stop. So the resultant force is 290 Newton. Okay. So I think that's it for today's class. So anyone has any question for anything that you want to ask for this chapter? Anyone? Everyone okay? No question? Okay, good. So it's actually not that hard. You just have to do a lot of exercise, right? So try to do the tutorials, right? Because for chapter 1, 2, 3, until the equilibrium of a particle, they are interconnected with each other, right? So last chapter, lecture 2, and then lecture 1, and then lecture 4. So lecture 1, 2, 3, 4 is interconnected with each other, right? So at the end of lecture 4, you should be able to solve everything based on the resolving and resolution of forces, right? So today is only for 3 dimension. Next week, we'll be learning about the equilibrium of particle. Means that the resultant force is 0. The system is not moving, okay? So for this one is pretty straightforward, right? Same thing like last week. It's just resolving and resultant of forces. You just have to know how to analyze the system and solve what you have, what data is given first. All right. So solve it small, solve it one by one, and I'm sure you'll be able to solve the overall problem. Okay. So this is the equation here. Usually, when you have more than one unknown and you cannot solve it, most of the time you will have to use one of this equation here, right? This is the equation. It's not pretty. It's not actually an equation. It's just telling you how to solve the resultant force and telling you how to find the angle for that force. Okay, right. So I think that's about it for today. So to those who have assigned yourself to do tutorials for lecture 3, please submit your video solution by Wednesday afternoon. All right. Please make sure that you get the correct answer first. Okay. If you do not get the correct answer, please do not submit your video solution. Check if you have the right answer first. If you don't have the right answer, try until you have the right answer, or you can approach me and we can work together for you to get the answer. Right? Once you have the answer, if your answer is the same as this one, then only you can upload the video solution. Right? For everyone else, you must try to do the tutorial session without looking at the video solution first. All right? Because the act of getting stuck, of not knowing what to do, that's where you learn how to solve that particular set of problem. Right? If you straight away look at the video solution without learning, without getting stuck on what to do, you will not learn anything. Right? So try to do it first. Never mind if you got the wrong answers. At least when you look at the video solution, you know where you get it wrong, right? If you don't if you straight away look at the video solution without learning anything, then you're going to have a problem. You're going to get confused, later on during tests, and later on during a final exam, right? And chapter 1, 2, 3, and 4 is actually the easiest part of this course, right? So this is where you need to score, which is on your test 1 later, because it's very easy, it's very straightforward. Resolving resultant is actually very easy to do as compared to the other lectures that we are going to learn in the following weeks. All right. Okay, so attendance. So attendance, please don't forget to sign your attendance. If you received an email about the attendance, please, okay, you need to submit your absence notice. You need to send in a letter. Okay, you cannot just send a picture of your MC or something like that, right? You have to make, come on, you are undergraduate students, right? You have to make a formal letter and say that, okay, attached is my MC for your reference, and so on and so on, right? Don't just give me like a picture of your MC. You have to have like a covering letter telling me, Assalamualaikum doctor, my name is this. I was absent for this, and so on, right? And attached with this letter is my MC or a letter from a letter from UMS saying that I have sports to do on that date or something like that, right? You must have a covering letter in the absence notice, right? So if you receive an email about your absence, please submit your letter of absence on ITEL. Okay, so this is the attendance. So I'll see you guys next week. Oh, no. Yeah, next week. Our lecture will be next week on Monday, but tutorial session that you will have to sign the attendance will be on Thursday, right? But I will post the attendance on the announcement section. You must always check the announcement section for any updates from me. Okay? So I think that's it for today. I'll see you guys next week. Bye.
Thank you,
Thank you,
Doctor.
Doctor.
Thank you, Doctor.
All right, bye.
Thank you, Doctor.
Bye. Bye-bye. Okay, bye-bye. Bye-bye. Okay, bye. Bye, guys.